Hello everyone. In this lecture I am going to discuss about different types of fatigue analysis method, then different types of fatigue design method and types of fatigue life estimation method. So, in this lecture I will discuss about the structural fatigue analysis method details, then I will discuss about fatigue design method details, and finally I will discuss fatigue life assessment method. This fatigue life assessment method also grouped into different categories. That related details also I will discuss. Apart from these things, I will also discuss about probabilistic method for fatigue life calculation. What are the different methods generally used for fatigue life calculation, that related different types actually I will discuss in this lecture. So, first of all I will just discuss briefly about what is called, what are the different types of or a fatigue analysis method, then fatigue design method, then fatigue life estimation method. After that, details about all these things I will discuss in subsequent slides. So, here what we can do, the method of structural fatigue can be grouped into following three categories, that is, you can say fatigue analysis method, then fatigue design method, then fatigue life estimation method. This is a systematic way. If we will go, then what happens, understanding of fatigue analysis will be very easy. So, first of all, what are the different generally fatigue analysis methods are there? Fatigue analysis method we can divide into two type of method, you can say. This method generally which approach the problem from different perspective, that means from different point of view. We group this fatigue analysis method into two methods. What are those two methods? One method is time domain method or time domain approach, another method is frequency domain approach. I told you that first of all I will just discuss briefly about these different categories of different analysis method, design method and life estimation method. After that, detail of these things I will discuss in subsequent slide. Fatigue design method, you can see, is grouped into four different types. What are those four different types? This fatigue design method generally four different methods are. One is called infinite life design, then second one is called finite life design, or you can say shape life design. This is also called finite life design. Okay, this you should keep. Then another one is called damage tolerance design and durability design. Though that related detailed things I will discuss in subsequent slides, I have already told you. Why this fatigue design methods is grouped into following four categories and what is its significance, that also I will discuss. Generally, fatigue is a very common form of part design, that you know. So, to avoid these economic losses which is caused by this fatigue damage, the concept of this anti-fatigue design has been proposed. So, this is actually whatever the things four types I am showing, this is fatigue design method which is based on anti-fatigue design, that you can say. This different approach is required because these different approaches are selected for different circumstances to ensure the greatest possible accuracy as well as applicability, because all design method cannot be applied in all purpose. For that is why what happens, it is grouped into different point of view, that you can say. Then fatigue life estimation method. Fatigue life estimation method in practical engineering application, you can see there are many kinds of fatigue life estimation method are there. So, among these the most commonly used method you can say methods are stress life analysis method, one is, another one is strain life analysis method, then third one is called stress field intensity method, and fourth one is called fracture mechanics method. Now, this stress life as well as stress field intensity method have a wide application in the field of, you can say, lot of manufacturing industry. One of the field here we can use welding. In the field of welding related manufacturing industry, this stress and stress field intensity related method is widely applied. We can group this estimation method in into following 4 common assessment method. What are those following 4 common assessment method that I am going to discuss, and here I will show you how it is complicated from one another. Have a wide application in the field of steel structure. I have already told you this method generally based on strain, stress as well as stress intensity factor, which I have already grouped in previous slide itself. So, there are 4 common assessment method, or you can say life estimation method used for fatigue life estimation of steel structure, such as bridges, offshore ships. They are generally these types of 4 different method have a wide application. So, what are these 4 different method? We can group into 2 main categories, or you can say the methods may be mainly categorized into 2 group. You can say one is called the global method, another one is called the local method. Among these 2 method, the global method is generally also have a very common name, that is called nominal stress method. So, the global method generally is the simplest and most commonly used method. The method which is generally categorized as the local method, that method have categorized into 3 different categories. You can say, what are those categories? The one is called hot spot stress method, second one is called effective notch stress method, and the third one again is, you can say, is called crack propagation approach. This method have a name. This method name is called linear elastic fracture mechanics approach. In short form, it is written as LEFM. What is this L? L means linear, E means elastic, F means fracture, M means mechanics, this approach. So, this is actually based on crack propagation approach, this you can say. So, these 3 methods are generally local method, whereas global method is generally nominal stress method, which I have already discussed. Now, from here what you can see, this first 3 method, that means this method, nominal stress method, hot spot stress method and effective notch stress method, generally these 3 method generally have a common characteristic factor. Common characteristic factor is that this method generally consider linear elastic theory. This method generally successfully predict the life of a engineering structure based on finite element method, or you can say boundary element method, where generally SN curve is a important consideration. This you should keep it in mind. That means, in this 3 method SN curve data is essential, while the 4th method which I have shown, that is called linear elastic fracture mechanics. In this method generally what happens, this SN curve data is not required, and this 4th method which is based on principles of fracture mechanics, this you should keep it in mind. The LEFM is based on principle of fracture mechanics approach. Okay. So, detail about all this method I will discuss in subsequent slide as well as in subsequent lectures. Okay. This hot spot and effective notch stress method as well is generally consider the stress where the stress concentration types of things is occur. So, that related things also more details I will discuss. Here I have shown a diagram, you can see. Generally, this nominal stress method is easy to use, and it is a simple method, you can say, because this horizontal axis represent complexity and this vertical axis represent accuracy. So, from these things you can see this nominal stress method, its accuracy is less, but what happens, comparatively less than other method, but its complexity is negligible, that you can say. That means, its complexity of these types of analysis is less. But then you see after that second categories, you see that working effort arrow I have shown here, you can say. This second category then is coming is called hot spot stress method. This stress method, it generally gives us a result which is better than nominal stress method, but what happens, it is little bit more complex than complex to analysis than nominal stress method. After that effective notch method, and finally the most accurate method is called linear elastic fracture mechanics method, which is complicated than other 3 methods that you can see. So, that I am showing here. Now, probabilistic method for fatigue life calculation also, there are different types of probabilistic methods are there. This probabilistic method for fatigue life calculation involve considering uncertainties in material properties, loading condition and other factor which influences the fatigue behavior. Okay. This factor which influence the fatigue behavior, that uncertainty generally considered in probabilistic types of method. That is why what happens, you can say this fatigue life estimation method you can grouped into 2 categories. One is called deterministic approach, another one is called non-deterministic approach. Deterministic approach I am writing, deterministic approach, another one is called non-deterministic approach. So, deterministic approach, which I have already told in earlier slide, that 4 different categories: nominal stress, hot spot stress, and what is called fracture mechanics, and what is called effective Nernst method, effective Nernst stress method. Non-deterministic approach means this probabilistic method you can say is called non-deterministic approach. This probabilistic method is generally useful where this deterministic approach may not accurately capture the variability and randomness inherent in fatigue phenomena. That is why this non-deterministic or probabilistic method is more accurate there. So, here are some 7 different common probabilistic method which are widely used for fatigue life calculation are shown. This first method is called probabilistic S-N curve method, second method is called Monte Carlo simulation method, then third method is called response surface method, that is in short form you can say RSM method. Then fourth method is called RBDO. The full form of RBDO is reliability based design optimization method. Then PFM, the fifth method is called probabilistic fracture mechanics method, Bayesian statistics and updating method, and seventh categories of method is called probabilistic damage method. So, these are the different types of probabilistic method which have a wide application in the field of what it is called fatigue life calculation, and this method generally used where main consideration is uncertainties. Okay. Now, I will discuss the details of structural fatigue analysis method first, then I will discuss about details of what it is called structural fatigue design method. So, these details now I am going to discuss one by one. So, previously whatever the things said, that is the brief categorization of fatigue analysis method, fatigue design method and fatigue life estimation method. Now, details about this thing now I will discuss one by one. So, I have already told you that fatigue analysis method is grouped into 2 categories, one is called time domain approach, another one is called frequency domain approach. Here one thing you should keep it in mind, generally this time domain approach, frequency domain approach have a application for cumulative damage calculation, that you can say. Cumulative damage generally obtained by time domain method is relatively more accurate than you can say frequency domain approach. So, that is why I have here written that it is more accurate, this time domain method, but this time domain method generally it take calculation time which is comparatively larger than frequency domain method, because it can take a long time to obtain its result. That is why you see here I have written, if the cumulative damage calculation is large, then it take long time to obtain its result. Whereas, in frequency domain analysis method, it can reduce the number of calculation first, that as it reduce the number of calculation, that is why it save computational time drastically compared to you can say time domain method. Now, in details I will discuss in time domain method what are the different steps generally we used to follow. We need to first calculate, or you can say calculate the time stress data. This time stress data generally we can obtain by using experimental monitoring, or you can say by using FE software simulation. FE means finite element software simulation like ANSYS, Abacus, some finite element other software also are available. By using those software, generally we need to first find the time stress data. This you should keep it in mind. This is the first step. Then in second step, this time history data is generally we need to convert into a fatigue load spectrum, because this time stress data directly you can put as a fatigue load data in your analysis. This we need to convert. For conversion purpose, generally we used a technique, that technique is called rain flow counting method. This rain flow counting method details also I will discuss in subsequent lecture. So, this rain flow counting method which generally use to obtain the stress amplitude as well as numbers of cycle, which generally obtained from this which data, this time stress data. This you should keep it in mind. So, first we need to calculate time stress data, second by rain flow counting method. This is a very important method, counting method. Generally this stress amplitude and number of cycle, you can say stress amplitude, and here I am writing NOC, number of cycle. These two things generally we need to calculate, and we need to convert this time stress data into a fatigue load spectrum, because directly we can't apply this time stress data for fatigue analysis for fatigue life estimation purpose, that we need to convert into fatigue load spectrum. So, it is also use fatigue load spectrum. It is also used to convert fatigue load spectrum. And in time domain method, once this fatigue load spectrum is input in the fatigue analysis, then we can predict the fatigue life. So, finally, fatigue life prediction methods and linear fatigue cumulative damage rule are used to calculate a component fatigue life. So, you see, so these three steps is required to use. So, finally, here we use fatigue life estimation method. Okay. So, first this data is required, then rain flow counting is required, after that fatigue life estimation method is required. Time domain method, the following steps are required, already I have told you, that means time stress data, rain flow counting method and cumulative damage theory is required. Generally for fatigue life estimation purpose, here the following fatigue life prediction methods are used. What are those methods? One is called nominal stress method, another one is called local stress strain method, and stress field strength method. Now, in frequency domain analysis, here generally we use power spectral density, you can say. In frequency domain analysis, generally we use power spectral density, or it is in short form it is called PSD. What is power spectral density? It is the measure of signals power content versus frequency. So, it is signal power content versus frequency, this you should keep it in mind. Whereas, in previous case you observe that there is required time stress data. Now, this power spectral density, it is a function of stress or strain as the excitation condition. Generally in frequency domain analysis method, we use the power spectral density function of the stress or strain as the excitation condition. So, first the PSD generally of a structure, this is generally obtained. You see, in previously I have shown that in previous method there is required only time stress history, that is required. So, here generally two components are required, material characteristics and time stress history is required for obtaining PSD of a structure. So, previously we observed that there is only required time stress history data. Then once the PSD is obtained, then using this PhD, this fatigue damage accumulation method is used and the SN curve of the material is also used. Then the fatigue damage and fatigue life of the structure are obtained using finite element analysis method using some finite element software package. Okay. So, first PhD is required to find, then we use a finite element analysis method using some commercially available software. Some of the software name I am just telling, like ANSYS, Abacus. So, these are the Nastran, some other software also are available, COMSOL. These are the different types of software are there. By using those software, generally we can what it is called predict the fatigue life. This frequency domain analysis is widely used in those structure which is subjected to random types of loads, like some of the random types of load example I am just telling, like widely used for vehicle, like you see motor vibration, wind vibration, airborne electronics, deep water pipes and other mechanical system. So, these are some of the example where generally this random load is generally it subjected to. In the frequency domain, the random load can be described by this power spectral density. The structure which is subjected to random load, there generally this frequency domain fatigue analysis is widely used, that you can say. Now, we will discuss about fatigue design method. I have already told you there are generally 4 common method of fatigue designs methods are available. What are those methods? One is called infinite life design, second one is called safe life design, third one is called damage tolerance design and fourth one is called durability design. So, first of all I will discuss about what is called infinite life design. So, in infinite life design, the main principle of infinite life design is to ensure that stress level here always less than the fatigue endurance limit. So, here whatever the you can say allowable stress, we will consider this stress should be always less than endurance strength, or you can say instead of sigma e you can write as SE, that means allowable stress sigma L less than endurance strength of the material strength. So, how to calculate endurance strength in details I have already discussed in previous lectures. So, there you observe these things. So, according to SN curve, generally when this condition is met, then fatigue crack will not appear in the part. That means, if in a structure if this allowable stress is less than endurance strength, then here it will not subjected to fail due to fatigue. That is why here I have written here fatigue crack will not appear in the part, this you should keep it in mind. So, in fracture mechanics, when the stress intensity factor inside a material is less than a critical value, generally a fatigue crack will not continue to expand. How it is? When I will discuss linear elastic fracture mechanics process, there I will discuss in details this stress intensity factor, then what happens critical value of crack length. So, what happens if it is not subjected to a critical value of this you can say crack length, then you can say this fatigue crack will not continue to expand, and theoretically here we can say it will have infinite life, that which is not subjected to any types of fatigue crack growth, then what happens its life will be generally you can say consider it is not subjected to fail due to fatigue. So, the infinite life fatigue design method was first proposed in former Soviet Union, and it was the earliest method for fatigue design, this also you need to know. But although infinite design method is a simple and widely applicable method, but here the design product are generally usually it is bulky and large, because in this infinite life design its generally here we are considering the it should not fail due to fatigue types of analysis.